bitumen and heavy oil gravities range from 6 to 23 API grades on this map, from Lloydminster and Cold Lake to Peace River to Wabasca, to the poorest 6 to 10 API bitumen grades in the Athabasca district. Of course, you know API stands for the American Petroleum Institute measurements of the grades of oil. The higher the number, the better the oil. Grades 40 are the lightest oil, grades down to 6 to 10 are the poorest quality. Experimental work began along the Athabasca River about 90 years ago because these surface bitumen deposits were the most accessible to mine. It wasn't until much later that a geologic understanding of the tar sands emerged that carbon footprints of these deposits in northern Alberta would vary so much. Over 30 years ago, I presented a paper titled Conventional Petroleum Assessments, Facts and Fallacies at a major international oil and natural gas conference in Calgary. This paper was published in 1980 in the CSPG Memoir 6, titled Facts and Principles, A World Petroleum Occurrence. This early bar graph illustrates the distribution of API gravities of cumulative oil production in the Western Canada Sedimentary Basin. That is from day one to the first time of this graph. Note the dominant mode of production in the high 30 to 40 API gravity range, with very little in the heavy oil and bitumen categories. Although much more light and medium as well as heavy oil and bitumen have been produced since this graph was made, the overall distribution pattern has not changed much. Along with many other experienced Calgary geologists, I am convinced there are still abundant supplies of conventional light oil remaining to be discovered in our basin. The question is, why are we still producing so much costly bitumen in the Athabasca area with the worst carbon footprints of 6 to 10 API gravity? I'll answer this question later. But before we go there, let's take a look at a tar pit on the other side of the world along the Silk Road that Marco Polo once traveled. I'll just introduce the distinguished looking guy in the middle wearing sunglasses. Bob Dyke, an internationally renowned geophysicist, is staring into this ancient Chinese tar pit. Robert Dyke became even better known when Queen Elizabeth named him a commander of the British Empire in honor of his role in discovering North Sea oil for the Brits. Bob Dyke was a great guy to have along during a month tour of oil basins in China in 1983. We were a specially invited group of petroleum geologists just as China was opening up its doors to the West. The Chinese are very proud of the Katamai heavy oil discovery and built a small museum in its honor, where our visiting international delegation learned about this field. It was discovered in 1955 with the help of Russian geologists. The Katamai field is now the third largest field in China. Heavy oil accounts for about 13% of current Chinese domestic production. However, some estimates project Chinese heavy oil production will increase to 60% in the next decade or two, resulting in huge increases of CO2 emitted to the atmosphere. That's me having my picture taken wearing a leather hat, made right here in Canada. The Zungar Basin is nestled between Mongolia and Kazakhstan, with Siberia due north. It's been called the most landlocked place on the face of the earth, and is located in Xinjiang province. Note the location of the Katamai field on the west flank of the Zungar Basin. Oil and natural gas induced seismicity or human-induced earthquakes. Seismicity is a useful term and includes small-scale or microseismic events in addition to more serious earthquakes. In 1995, I presented this paper at the AAPG National Convention in Houston, and several months later to the CSPG Annual Convention in Calgary. The AAPG, of course, is the American Association of Petroleum Geologists, with a worldwide membership of some 35,000. The CSPG, headquartered in Calgary, is a membership of about 3,500. After both presentations, the silence from the oil patch was deafening. I was concerned that only seismologists were interested in this subject. Petroleum geologists and exploration geophysicists showed little interest in published reports of oil and gas-induced earthquakes located in important producing basins around the world. Case histories from Western Canada, the U.S., France, Uzbekistan, and Kuwait, reviewed at these 1995 Petroleum Geology Conventions, will be displayed again tonight. This is a map of natural earthquake risks in the U.S. extending into southern Alberta. There are 4 important points to explain on this map. The first is the highest risk of natural earthquakes along the west coast of California, caused by the action of plate tectonics and the geologic process known as subduction. The area in red is a secondary zone of significant earthquakes covering the eastern half of California and through the Basin and Range province of Nevada. The site of the ill-fated proposed Yucca Mountain radioactive waste storage facility is located in the seismically active area of southern Nevada. The secondary seismic zone continues through western Utah, Idaho, western Wyoming, and Montana into southern Alberta. The area in yellow represents the lowest risk of natural occurring earthquakes and is very misleading. There are many dozens of well-documented and published accounts of induced earthquakes as a result of oil and natural gas operations that don't appear on this map. These human-induced earthquakes occur in the major oil-producing states of Texas, Oklahoma, Kansas, the west slope of Colorado, and California. The fourth important point about this map is the area known as the New Madrid Tectonic and Earthquake Zone in southern Illinois and adjoining states, located between the Gulf of Mexico and the Great Lakes. About 200 years ago, a series of magnitude 8 earthquakes occurred in the New Madrid earthquake zone that rang church bells in Washington, D.C. and Philadelphia, 750 miles away. These earthquakes also changed local flow patterns of the Mississippi River. This is important to understand because it proves that catastrophic earthquakes in recent times have occurred within the North American continent and have nothing to do with the current subduction process and plate tectonics along the west coast. The reoccurring geologic history of the Peace River Arch is well documented in the Geologic Atlas of the Western Canada Sedimentary Basin. This atlas was published in 1994 by the CSBG, the Alberta Geological Survey, the Alberta Research Council, and the Geological Survey of Canada. According to this atlas, which is accepted by everyone as the geological Bible of Western Canada, the Peace River Arch is closely compared with the geologic history of the New Madrid Tectonic and Earthquake Zone. This comparison is evidence of serious earthquake risk on the Peace River Arch and potential hazards to a nuclear power plant that might be located.